So now we'll discuss about rise time budget. This is very important in the examination point of view. So as I told you already in the previous video, rise time budget determines the dispersion limitation. Dispersion happening due to the propagation of the different signals with different velocities at different wavelengths. So now here, it is very convenient method for determining the dispersion limitation of the optical fiber link, and especially used for digital systems. And whenever I have an optical system, and in that optical system, the total rise time is given by T system is equal to sigma I is equal to 1 to n Ti square whole to the power of 1 by 2. So here Ti is the time or rise time produced by each component in the system. And there are 4 different elements which can affect total system speed. That means simply they will limit the system speed. The first one is transmitter rise time, which is given by Tx, and second one is group velocity dispersion rise time, which is indicated by TGVD, group time velocity dispersion, and modal dispersion rise time of the fiber, and the fourth one, the receiver rise time, which is represented by TRX. So these are the 4 factors which can affect or which can limit the system speed. Okay. And in general, the transmitter rise time TRX is due to light source and its driving circuit. So you need to consider the response time of the light source and driving circuit. Both will contribute this transmitter rise time. And receiver rise time. So when you consider receiver rise time, it is because of the response of photodetector what you are using and 3 dB electrical bandwidth. 3 dB electrical bandwidth of the receiver front end. So these are the main 4 factors which can affect the system response. And generally, the response of the receiver front end, which can affect the receiver rise time, is given by the equation G of t is equal to. So simply it is a first order low pass filter response with the step input 1 minus exponential of minus 2 pi b t u of t. Take this as t greater than or equal to 0 and for t less than 0. So this is a step signal. And what is BE here? In this equation, BE is electrical 3 dB bandwidth of the receiver. And in general, you can take the receiver front end rise time in nanoseconds, that is given by TRX is equal to 350 by B in terms of electrical bandwidth. And the rise time of the transmitter, the rise time of the receiver is usually taken to be in the time interval of g of t is equal to 0.1 and g of t is equal to 0.9, and that is, you can take this as 10 to 90% of rise time. So simply this is given by this expression Trx is equal to 350 by B. Okay, and the fiber rise time GVD, the fiber rise time GVD is given by TGVD is equal to modulus of D L sigma lambda. So here sigma is the half hour spectral width of the source, D is the dispersion, L is the length of the fiber, and the bandwidth in a link of length L is given by Bm of L B naught divided by L to the power of Q. So here is Q is a constant and which can be taken. Q is equal to 0.5 is going to indicate steady state equilibrium model, and if Q is equal to 1, modulation mixing. So if Q is equal to 1, mode mixing happens, and the reasonable value of Q is taken based on the experimental procedures, that is 0.7. Okay, and you can express this beam width in a link as 1 by Bm is equal to sigma n is equal to 1 to n 1 by Bn whole to the power of 1 by Q whole power Q. So this is another expression that is proposed for bandwidth based on the curve fitting of experimental data. And here Bn is the bandwidth of the nth fiber section. If I have to have multiple sections of fiber, so Bn is the nth fiber section bandwidth. This expression can also be expressed in terms of time domain as Tm of n is equal to sigma n is equal to 1 to n Tn of whole to the power of Q whole power Q. So now here this Tm of n is called pulse broadening, occur over n cable sections, n number of cable sections, in which the individual pulse broadenings are given by simply Tn, individual pulse broadenings. Okay, and now the task is to find out the relation between the fiber rise time, and 3 dB electrical bandwidth or 3 dB bandwidth. So to get the relation between fiber rise time and 3 dB bandwidth, the optical power emerging out from the fiber is assumed to have a Gaussian temporal response, and that is given by the expression g of t is equal to 1 by root 2 pi sigma e to the power of minus t square by 2 sigma square. And here sigma is RMS pulse width RMS pulse width. The Fourier transform of this function g of t, Fourier transform of g of t is g of omega is equal to 1 by root 2 pi e power minus omega square sigma square by 2. I am not calculating here, you can try. So g of omega is equal to 1 by root 2 pi e to the power minus omega square sigma square by 2. Okay. And here g of t 1 by 2 is equal to 0.5 g of 0. So this is the half maximum value of the Gaussian value, and t of 1 by 2 t1 by 2 is the time required to reach this half maximum value, where 0.5 is equal to 0 of 0 is given by 2 ln of 2 whole to the power 1 by 2 sigma whole to the power 1 by 2 sigma. And based on this, the time full width maximum half maximum full width half maximum of the pulse is given by the expression t FWHM is equal to 2 into T half is equal to 2 sigma 2 ln of 2 whole to the power of 1 by 2. Okay, 3 dB optical bandwidth. So here the 3 dB optical bandwidth is simply defined as modulation frequency at which the optical power has fallen to 0.5 or half of the zero frequency value, and that can be expressed as f3 dB is equal to b3 dB bandwidth. 3 dB bandwidth is equal to 0.44 divided by t FWHM, that is full width half maximum time period. Okay, and this is the relation between the two, 3 dB bandwidth and time. And now for 3 dB bandwidth, the optical power link and rise time for model dispersion is given by T mod is equal to 0.44 divided by B. T mod is given by 0.44 by Bm, which is also written as 0.44 L to the power of Q B naught. And this can also be expressed as T mod is equal to 440 divided by Bm is equal to 440 L to the power of Q divided by B naught. We have T mod and TGVD and all the things. So based on this, the total system rise time, generally it is taken as Tx square plus T mod square plus TGVD square plus T receiver time 1 by 2. And based on the expressions what we have, you can express this as Tx square plus T mod is given by 440 L to the power of Q by B naught whole to the power of 2 plus TGVD is expressed as DL sigma. So this is sigma lambda square L square plus this is given by 350 by B Rx whole square whole to the power of 1 by 2. So this is the rise time concept. Thank you for watching.